Hi, and welcome to this GameMaker Studio video course. In this course, you will learn how to use GameMaker Studio to create your own platform game. This course will be made up of 8 sections covering the GameMaker Studio interface, the basics of GameMaker language or GML for short, creating objects and assigning properties to them, basic animation, movement and object interaction, advanced movement including friction, gravity and other essential aspects, implementing gameplay features, and basic anime artificial intelligence. During the course, you will learn the basics of GameMaker language. You will also learn good practice for naming objects and how the main resources are created and used in the creation process of games. By the end of the course, you will have created a level for a platformer game including enemies, obstacles, artificial intelligence, a goal, and a finish to the level. You will then have the required knowledge to continue with the game created in this course or to start your very own game. This course will focus on GameMaker Studio Professional, which is the newest version of GameMaker and allows the user to export games not only for Windows but for mobile devices such as Android and iPhone. You can also export to Mac and Linux computers. For the free version of GameMaker Studio, you can also export to Mac, Windows, and Windows 8 formats. Purchasing the Professional or Master Collection allows for extra export options to be purchased at an extra cost. If using the free version, you will be limited in the number of resources you can use in a single game. The resource limitations are as follows: max of 5 rooms, max of 20 sprites, a max of 10 sounds, a max of 15 objects, a max of 5 backgrounds, a max of 5 timelines, a max of 10 scripts, a max of 5 fonts, a max of 10 paths. Finally, you may only have a max of 5 included files. You may download the free version of GameMaker from www.yoyogames.com/studio. The GameMaker interface can be confusing on first look, as it's made up of a lot of unexplained icons and buttons. In this section of the course, I will be explaining and showing what these buttons do. After learning the interface, using GameMaker is a breeze. The first thing you see when opening GameMaker Studio is the New Project window. In this window, you can do things such as loading your most recently opened game or creating a new one from scratch. However, there is a lot more you can do from this window. The first screen shows the welcome screen. Below this, you have your recent files. The recent files section can be used to load your most recently opened games. If this is your first time opening GameMaker, you probably won't have any recent files to open. If you do, simply click on the file name in the list to open it. At the top of the window, you can see 9 tabs. These tabs include Welcome, Open, New, Import, Release Notes, Demos, Tutorials, News, and Licenses. You can use these tabs to get to different sections of the window. Clicking on Open will take you to the Open section of the New Project window. Here you can open any files you have saved to your computer. In the left box, you can browse for your saved file. Your game file will show in the right box. Double-clicking on a file in the right box will open that file ready for editing. If you don't like the built-in File Explorer, you can click on the grey button to the right of the Open File text box. Clicking on this button will show the default Windows Explorer, allowing you to find your game file. Once you have found your game file, click the Open button. Clicking on New will take you to a rather empty window, where you can create a new game. You should see 2 text boxes, one labelled Project Directory and another labelled Project Name. You can use these to set up your new game. Once you have your desired option set, click the Create button. This will create your game file and open it ready for use. Clicking on the Import tab will take you to a screen where you can import games from either GameMaker Studio or an older version of GameMaker. You will notice a drop-down box labelled Filter. Clicking on the arrow to the right of it will display a drop-down list with different formats from previous versions of GameMaker. You can use the Import tab to load any of these file types. The Release Notes tab is rather self-explanatory. In this tab you can see all the release notes from the newest GameMaker version and from the older versions as well. The Demo tab allows you to browse through and open demo projects that come with GameMaker Studio. The Tutorial tab has collections of tutorials which may also help you. The News tab shows news directly from the Yo-Yo Games website. The Licenses tab shows the licenses for external software included with GameMaker Studio. You should now be able to create your own project using the New tab. Simply name your file, choose where you want it saved, and hit Create. Once you do this, you will be presented with the main GameMaker Studio interface and be ready for the next topic. In this video, you learn about the new project window in GameMaker Studio. You can now load, create, and import projects as you wish, bringing you one step closer to being able to design and create your very own games. In the next topic, we'll be learning the main interface of GameMaker Studio, seeing what each button does and how information is displayed. In this part of the course, you will be learning about the main GameMaker interface. The first thing you will notice when opening a project or creating a new one is the buttons along the top of GameMaker and the list of resources down the left side. The buttons along the top allow you to quickly create resources, run your game, open and save projects, and access game settings. The first button on the far left allows you to start a new project. Clicking this will open the new project window. The second button allows you to open a project. Clicking it will bring up Windows Explorer, allowing you to browse for the project you wish to open. The third button allows you to save your project. Clicking it will bring up a progress bar or two while GameMaker saves. The fourth button allows you to create an executable copy of your game. Clicking it now will display a message telling you your game needs at least one room. I will show you how to create a room later on. The button shaped like a green triangle will run your game. The button shaped like a red triangle allows you to run your game in debug mode. This is just like running it normally, except you are presented with another window to watch certain aspects of your game while it runs. The button that looks a bit like a red power button or stop sign stops the web server. You won't need this when creating a game for Windows. The button shaped like a broom clears the asset cache. You probably won't need this, but if you ever have issues running your game, click this button and try again. The ninth button is the first of the resource creation buttons. It is shaped kind of like a green Pac-Man. This button allows you to create sprites for your game. A sprite is the base of any game. They are basically the graphics of your game. These can hold animations or static images. There will be more on this later on. The second of the resource buttons is for creating sounds. Clicking this will create a sound resource. From there you can load sounds into your game for later use. The third of the resource creation buttons is for making backgrounds. These can be set up as backgrounds for your game levels. The fourth of the resource buttons will create a path. Paths allow you to create pathways and have an object follow it during your game. The fifth of the resource creation buttons creates a script. A script is a piece of code that any object in the game can access and run. They can be very helpful when multiple objects are meant to behave the same way. Objects will be explained soon. No prior programming knowledge is required for this course. You will learn how to write code and how it works in GameMaker Studio later on. The sixth of the resource buttons is for creating shaders. Shaders allow you to manipulate what is drawn to the screen in real time, creating complex graphical effects, making them one of the coolest features of any game engine. The seventh of the resource buttons is for creating fonts. These are used in drawing text in GameMaker. The eighth resource button is for creating timelines. Timelines can execute certain actions over times that you set. The ninth resource button is for creating objects. Objects are the most important part of any GameMaker game. They hold most, if not all, code in your game and draw sprites to the screen. The 10th and final resource button creates a new room. A room is like a level in your game, and you must have at least one to even play your game. Rooms hold all objects and allow you to place objects where you want inside them. Basically, no room, no game. In this sense, GameMaker differs from all other game engines, both 2D and 3D. The next button brings up the global game settings. These settings are separate for each project. The next button, shaped as a green plus symbol, allows you to install and activate extension packages that you may have downloaded. The final button shows a green circle with a question mark. This brings up the GameMaker help file where you can find information on nearly all things included in GameMaker Studio. To the right of all the buttons we just walked through, there is a drop-down list labeled Target. Click the arrow and you will be shown all your available target platforms. Changing this will make GameMaker run your game and export to the target you choose. In the free version, you will only have 3 targets available. If you have purchased extra export modules, then these will be shown here. To the right of the target drop-down list, you can see another one labeled Configuration. Configurations in GameMaker make it easy to quickly switch between different splash screens, icons, and included files. That sums up the main toolbar. However, you may have noticed the resource tree on the left of the main GameMaker window. When creating resources, they will show under the relevant groups. Sprites will show up the top group labeled sprites. Objects will show in the group labeled objects, and so on. You can create your own groups to keep things more organized. To do this, simply right-click somewhere in the group that you wish to make your own group in and choose the Insert Group option. You can then name your group and add resources to it. Always keep your projects as organized as possible. This makes working on games a lot easier, especially when they include hundreds of different resources. You should keep your resources grouped in categories, for example enemies or ground objects. In this video we learn about the main interface of GameMaker Studio. You should now be able to create and organize resources for your games. In GameMaker Studio there are many resources. With these resources come new interfaces, and with new interfaces you can find more confusion. In this topic we will be learning the interfaces for the resources that we will be using to make our platform game. The first resource we will be using is a sprite. If you have watched the topic on the main GameMaker interface, you will know how a sprite is created. If not, you will see it now. To create a sprite, click the button that has what looks like a green Pac-Man on it. This will display the sprite creation interface. Here you can name, load, and create your sprite. To name your sprite, simply type your desired sprite name into the text box labeled Name. I would advise using a small keyword to help you separate sprites from objects. Things such as adding SPR underscore to the start of a sprite name will work best. Next you will either want to load or create a sprite. For now, simply load an image from your computer. Something small will work best. Click OK to save your sprite. It will then show under the sprite group in the resource tree. Next we will look at the object interface, one of the most used interfaces in GameMaker. To create an object, click on the button shaped like a green ball. This will create an object and show the object interface. From here you can change the object settings, program the object, and give it a sprite. To start off, let's give the object a name. Call it something similar to the sprite's name. The name cannot be exactly the same. To solve this issue, I advise adding obj underscore to the start of the name like we did for the sprite. Next, let's give it a sprite. To do this, click the button to the right of the No Sprite text, then choose the sprite you want from the drop-down list. The object will now look like your sprite in your game. You can see two grey rectangles labelled Events and Actions. Events are things that happen during your game, for example the player pressing a key or clicking on the screen. Clicking Add Events allows you to add one of many events to your object. You can then use actions to tell your object what to do when certain things happen in your game. All this will be explained in greater detail as we begin to create the game. For now, click OK to save the object. It will then show in the resource tree under the object group. The last and most important interface we will be looking at is the room interface. Create a new room by clicking the button shaped as a blank white window. The room interface will then show and you will be able to see a blank grey rectangle with a grid. This is your game creation area. You can add in all your objects and design levels in this space. To add an object to your room, make sure its name is showing in the text box below Object to Add with the left mouse. If it isn't already showing, select it the same way we added our sprite to the object, then left-click somewhere in the room to add it to the game. In this course you learnt the very basics of the sprite, object, and room interface. You should now be able to load a sprite, attach it to an object, and put it into a room. You will learn more and become familiar with these interfaces as we create the game. In the next topic, we will learn about GameMaker Studio's preferences and how you can customize GameMaker's look and feel. GameMaker Studio has a number of preferences allowing you to customize the look and feel of your creation environment. Such preferences include changing the skin and choosing your own text, graphic, and sound editors instead of using the default ones. To access the Preferences interface, go to File, and then Preferences. The first section of Preferences allows you to change the basic settings of GameMaker, things such as skin, number of backups to make of your game, and more. These options are relatively simple to use. Most just require you to check or uncheck a box to change them. To change the skin, click on the skin you want to use and click OK.
You will then need to restart GameMaker for the changes to take effect. More skins can be downloaded from the GameMaker community. The Forms tab has more basic options for the sprite, object, and room interfaces. These options include things such as the default background color of the rooms and whether or not to have the grid on. The Scripts and Code tab allows you to change font properties for keywords in the script editor. You can change things such as colors of keywords and functions as you type them, for example showing function names in green. The Editors tab is where you can choose your own editors for sounds, images, and code. Simply browse for the executable file of your chosen editor. The next time you go to edit a resource of that type, your chosen editor should be open instead of GameMaker's default one. For example, if you want to use Notepad for your code editing instead of the code editor included with GameMaker Studio, then you can click on the grey button labelled with 3 dots to the right of the text box beneath the words Code Editor. Browse to C, Windows, System32, and then find the notepad.exe. This will set Notepad as the default code editor for GameMaker. The rest of the tabs are for more advanced settings for things such as developer settings for Android or iPhone games, depending on the modules that you own. We will not be using these settings for our game. If you're using Windows 8, you may need to download Microsoft Visual Studio 2012 for your games to run. Once this is downloaded, change the path in the Windows 8 tab to suit its install location. To know for sure if you have to download it or not, create a blank room and run the game. GameMaker will prompt you if the settings have not been entered properly. Again, this depends on your operating system and the version of GameMaker that you are using. In this course, you'll learn about the main preferences in GameMaker. You can now change the skin, edit text, colors, and fonts for the code editor, and change the default editors for your resources. You can customize GameMaker Studio as you see fit. In the next topic, we will learn about the drop-down toolbar. The final part of the GameMaker interface is the drop-down toolbar. The drop-down toolbar includes File, Edit, Resources, Scripts, Run, Window, and Help menu. The drop-down menu is at the top left side of the main GameMaker Studio window. This menu holds many options, allowing us to do everything from creating a new project to finding help and asking questions about GameMaker. The File drop-down menu holds all your saving and loading functions, as well as the preferences and exit buttons. This menu is one of the most used in GameMaker, aside from the Resources menu. The first option is New Project. This button allows you to open the New Project window, allowing you to create a new project. Next you have the Open Project button. Clicking on this will show the default Windows Explorer, allowing you to browse for your desired GameMaker project. The Import Project button does the same thing as the New Project button. Clicking on it will show the New Project window and allow you to access and use the Import tab. The Recent Projects option is an extendable option. Hovering your mouse over it will show more buttons and allow you to load your most recently opened projects with one click. Clicking on the Save button will save your game. Clicking on Save As will show a small dialog allowing you to choose the path you want to save to and also the name of the project to save. Clicking on Save All will save all parts of the project. Clicking Save as normal will only save the parts of a project that have been changed. This option will save all parts regardless of whether or not they have been changed. Clicking on Export Project allows you to export your project as a compressed GameMaker file, or .gmz as most of the GameMaker community will call it. This is a single file that stores all parts of your game inside of it for easy storage and transfer. It will hold everything from sprites to the included files set for your projects. The Create Application option allows you to create a standalone application of your game. This will work off the export you have chosen in the target drop-down list. Clicking on Preferences will take you to the Preferences interface where you can change the settings of GameMaker Studio as shown in the previous topic. The final option in the File drop-down list is the Exit option. This is rather self-explanatory. It simply exits GameMaker Studio. You'll be asked to save your project if you have not already done so when clicking on this option. The Edit drop-down menu holds options regarding the resource tree. The first option is Create. Clicking on Create will create a new resource. The type of resource depends on the section of the resource tree you have selected. For example, if you have the Sprites section selected, it will create a new sprite. If you have the Rooms section selected, it will create a new room, and so on for all the other resource types. The duplicate option will create a duplicate of the current resource you have selected in the resource tree. The create group option will create a new group in the section of the resource tree that you have selected at the time. You will be prompted to name the group before it is created. The delete option will delete the current resource that you have selected in the resource tree. You will be prompted to confirm this option after you have chosen it. The rename option will rename the current resource that you have selected. The properties option simply opens the selected resource the same way double-clicking on the resource itself would do. For example, if you have an object selected, it will open that object for editing. Clicking on Find Resource will open a small dialog allowing you to search for a resource name and have GameMaker Studio search through all the resources for the name you enter. Clicking on Expand Resource Tree will expand all parts of the resource tree. This includes all groups that you have made yourself. Collapse Resource Tree does the exact opposite and closes all sections of the resource tree that are open. Clicking on Show Object Information will bring up a new dialog with all the objects listed. This dialog shows all the objects' events, code, and basic settings in a text-only format. Clicking on Transparent Background Settings allows you to edit the default color of any transparent areas in the sprite and background resources while editing them. The default is a 2-shade gray grid. You may change the grid color and size, or you can set it to a single color. The Resources menu holds options for creating and defining resources for your game. The first section of options is simply for creating all the basic resources, including sprites, sounds, backgrounds, paths, scripts, shaders, fonts, timelines, objects, and rooms. Beneath these you have the Change Global Game Settings button. Clicking on this will take you to the Global Game Settings menu, which can also be accessed from the bottom of the resource tree. This menu allows you to define settings for your game. Some of the settings include copyright information, author names, version numbers, and more. There's a tab for each available export module in this interface. This will vary depending on the export modules that you own. Clicking on Select Extension Packages will bring up a new interface which allows you to install and activate extension packages from GameMaker. Extension packages can be downloaded from the GameMaker community and allow users to create functions and extend GameMaker in many ways. Clicking on Define Constants will bring up another interface with a small table on it. This table can be used to enter a variable name and a value for those variables. This variable can then be used throughout your entire game without the need to initialize it through GML code. When typing it in, it will show as a built-in variable would. The Scripts menu holds options regarding the programming side of GameMaker Studio. For people without programming knowledge, you probably won't understand these features, however they should become clearer as you progress through this course. Clicking on Show Inbuilt Variables will show a dialog with all the inbuilt variables in GameMaker. Clicking on Show Inbuilt Functions will show a list of all the available functions in GameMaker. Clicking on Show Extension Functions will show a list of all the functions included with any extensions that you have activated. If no extensions have been activated, the list will be blank. The Show Constants option will show a list of all the constant variables in your game. This list will include the built-in constants and any constants that you have created. Clicking on Show Resource Names will show a list of all the resource names in your game. This list includes all resource types. Clicking on Search in Scripts will bring up a small dialog where you can search for keywords in any scripts that you have in your game. You can use the checkboxes to narrow your searches. Clicking Check Resource Names will make GameMaker do a quick check to see if there are any name conflicts. Any conflicts found will be listed for you to see. Clicking on Check All Scripts will make GameMaker check your scripts for errors. Errors will be listed for you to see. The Run menu holds options for running your game. The first option is Run Normally. This is the same as clicking the green Run button on the main toolbar. It simply runs your game. The next option is Run in Debug Mode. This option is the same as clicking the red Run button on the main toolbar. It runs your game in debug mode, allowing you to watch certain things in your game. Clicking on Clean Build will first clear the asset cache before running your game. This ensures that all data has been reset and is recompiled when running. Clicking on Configuration Manager will show the Configuration Manager interface. Here you can create and edit configurations for your game. The Configurations option is a secondary menu. It holds any configurations that exist within your game and allow you to change configurations quickly. This can also be done in the main toolbar. The window menu holds options regarding the sub-windows within GameMaker. Clicking on Cascade will arrange the open windows in a neat descending order. Clicking on Show Compile Form will display the compile form that shows while running your game. The compile form allows you to track a game's progress as it is built and as it runs. Clicking on Arrange icons will arrange the minimized property windows. Clicking on Close All will close all the open property windows. Finally, we have the Help menu. The Help menu holds shortcuts to help you find files and other helpful pages. Clicking Contents will open the GameMaker help file where you can find information on nearly every aspect of GameMaker. The Extension Options opens a small interface where you can view help information on the extensions that you may have downloaded. Not all extensions will have help files supplied. Clicking on Open Tutorial panel will open the tutorial panel where you can browse, download, and view a wide range of tutorials. Clicking on News will open the news window inside of GameMaker. You can view information directly from the Yo-Yo Games website. Clicking on Website will take you to the Yo-Yo Games website. Clicking on Forum will take you to the GameMaker community, or GMC for short. You can ask and answer questions based on GameMaker. You can also post about games you have released or have general discussions with thousands of people in the community. The Knowledge Base option will take you to the Yo-Yo Games Knowledge Base, where you can find information on bugs that you may have experienced and how to fix them. Clicking on Release Notes will open the Release Notes page in your default browser. You can see notes on the latest updates for GameMaker Studio. Clicking on Help Desk will take you to the Yo-Yo Games Help Desk, where you can ask questions directly to the Yo-Yo staff or browse through other people's questions to see if they have had the same problem as you. Clicking on Report a Bug will take you to the Yo-Yo Games website, where you can report a bug that you may have found in GameMaker. Make sure you check the recent bugs before reporting to avoid reporting the same bug twice. This option is not for bugs in your own code. This is for bugs in the GameMaker Studio software itself and should only be used for such things. Clicking on Open GameMaker in Explorer will open up the GameMaker folder in Windows Explorer. Here you can find all the files GameMaker uses to run. Clicking Open Project in Explorer will open the project folder that you are currently using. For example, if you have a project called Game, open the folder that holds the data for that project. Clicking on Update License brings up a small dialog where you can enter your license key and have it updated. This is used when buying export modules. After purchasing and receiving your license key via email, you would paste the new license key into the text box and click Submit License to update it. Then you should restart GameMaker, and assuming all goes well, your modules should be available for use. Finally, clicking on About GameMaker will show a small dialog with information on the current version of GameMaker that you are using. It will also list the license key and the export modules that are available for use with that license key. That's it for the drop-down toolbar. You should now know what each option does and how they can be used. That sums up this section of the course. The next section will be on the basics of GameMaker language. You will learn how to use GameMaker's programming language and be on your way to programming your very own games. In this section we will be learning the basics of GameMaker language, or GML for short. After watching the parts included in this section, you should have a fair understanding of how GML works and be able to follow on with the rest of the sections. Firstly, what is GML? GML is GameMaker's built-in programming language. Once you get your head around the basic concepts, it is easy to learn, and if used correctly, it can be extremely powerful. Programming in GameMaker is done within a common structure. An object holds events. These events are executed when certain things happen within a game. For example, the create event is executed once when the object is first created. The draw event is used to draw things and is executed a number of times a second. There will be more on this later on. For now, simply think of an event as a significant event that has either happened or is happening during the game. Events are where we type our code or use drag-and-drop functions. A drag-and-drop function is a simplified way of programming in GameMaker. They are pre-written pieces of code that instead of making you type out everything, they simply supply you with a simple interface where you can customize the way they work to suit your needs. While these are helpful, they are limited due to the main code not being editable. For this reason we have code blocks. A code block is a section of code which you can add to an event. For example, you may tell an object to do something in the create event. To do this, you would go into an object, add a create event, and then add a code block in which you can type your GML code and tell the object what to do. You will see how this works during this topic. To add GML into your game, we first need to have an object created. To do this, click on the green ball in the main toolbar. You can also go to the Resources drop-down menu and click Create Object. Once this is done, you will be met with the object interface. Let's start by giving it a name. In the text box labeled Name, type obj variable. This is only an example name. In your games you can use whatever names you want, but it is advised to use a keyword or letters to single out your resource types. In this case, we are using obj to signify that this is an object. Next, we need to add an event for our object to perform. Click on Add Event near the bottom of the object interface, then in the menu that shows, click on Create. This will add a create event to our object, which will now show in the grey Events box. The Events box is the left grey box labelled Events at the top. If it isn't already selected, click on the event to select it. Now click on the Control tab on the far right. The Control tab holds a few drag and drop functions for more advanced games. The one we want is under the Code section. We are going to use the far left icon, which looks like a piece of paper with writing on it. This is a code block. Click and drag this onto the Actions box, which is to the right of the Events box. This will add the code block to our event ready for use. This can also be done by right-clicking once on the icon. Once this is done, you will be presented with a new interface in which we can type our GML code. We are now ready to start typing. The first thing to learn about GML is what a variable is, and how to use it. A variable can be seen a lot like algebra. They are key letters or words that hold a value. This value can then be changed or used for things like equations. To create or initialize a variable, you must first state the name of the variable. Let's use the letter A for now. A variable name can include numbers but must not start with a number. You must always use a letter first. Now we have our variable name, we need to give it a value. This is done by simply typing equals and then the value that you want. For now, let's type 5. A variable must be created or initialized before it can be used. Simply typing the variable name and giving it a value in the create event works fine for this. If you should try to use a variable name in a different event and you have not initialized it in the create event first, your game will give you an error as it will not know what the variable is. If you have a variable that you do not need to give a value, simply set it to 0 or -1 to start with. This way it has been initialized and will not affect your game until it is needed. An important thing when using GML is to always remember that it is case sensitive. This means that a lowercase a is not the same as an uppercase A. This goes for all things in GML. Okay, we now have a variable a set to 5. Now let's create a new variable named b and give it a value of 2. Simply type b equals 2. We can now add, multiply, subtract, and divide our variables by each other. Let's start off by multiplying them. We're going to use what is called a function so that we can see our value when the game is run. Functions will be explained in detail in a later part, so for now just type show_message and add 2 brackets to the end. This function will show a message saying whatever we tell it to. We are going to use the message shown to see our values. In between the brackets, type a times b. This will show a message with our final value in it, which should be 10. Remember again that GML is case sensitive. So because we use a small a and a small b to initialize our variables, we must again use a small a and a small b. Should we type an uppercase A or B for one of those values in the showMessage function, we will be given an error. Click the tick on the top left side of the code interface. Then create a room and add the object to it. Now run your game. If all goes well, it should show a message dialog box with the number 10 in it. So that is the very basics of creating and using variables, but there is a lot more to know about them. Variables can be used in any event, but must first be declared or created. If you do not declare the variable, you will be given an error and your game won't work. There is a way to create a temporary variable for one event though. To do this, type var, then your variable name, equals, and then your value. This will create a variable that is only active for that code block. Once that code block is over, the variable will be cleared from memory, meaning it can't be referenced in any other events or blocks of code. What we created earlier was called a local variable. It is available for this object and this object only. You can't access it in any other objects just by typing its name as you would in this one. There are two ways you can access one object's variable in another object. The first is to type the object's name, then add a full stop, and then type the variable name. The second is to use what is called a global variable. A global variable can be accessed in all objects and will be active from the time it is created in-game to the time the game ends. To create a global variable, simply type global dot and then the variable name. This will make the variable global for all objects in your game. However, the variable won't be accessible by other objects until it is initialized. So if you try to access it in another object before this object has had the chance to create it, you will get an error. That sums up the basics of variables. You will see and get a better understanding of how they are created and used as we create our platformer game. You should now have a fair understanding of what a variable is and how to use one. In the next part, we will learn about functions in GML. In this part, we will be learning about functions. Functions are the main structure of GML code. Without them, you wouldn't be able to do much apart from basic mathematical equations. In the last part, we used the showMessage function. This function is used to display a message to the player. In this part, we will be going deeper into what a function is and how it works. A function is a block of code that has a name and can be used in any part of a program. An argument is data given by the programmer so that the function can run correctly with small changes to the return result depending on the arguments given. GameMaker has many inbuilt functions which can be used. These functions provide the basic building blocks of GML code and are used extensively in most, if not all, GameMaker games. To start with, we will use the drawText function. This function is used in the draw event to draw text at a given position in your game room. To begin, add the draw event to a new object. Now add a code block and we are ready to use our function. Remember, when writing code in GameMaker it is case sensitive, meaning that an uppercase A is not the same as a lowercase a. The main thing to remember when using functions is that instead of spaces they use underscores. Now let's type our function name. Type draw underscore text. It should show in a different color to normal text if you typed it correctly. Functions always have an opening and closing bracket after the name. We type our arguments between these brackets. If you click between the brackets and look at the bottom of the code interface, you can see the arguments required to make this function work. For the drawText function, we need to supply the x, y, and str, which stands for string, arguments. X and y are used to supply the horizontal and vertical positions in the room. A string is a data type which holds text. This should be used for giving a message to the player or writing text onto a button. So when writing our string, we are writing text for a game to use. In this case, the game will draw our string to the screen. In between the brackets, type 0 for x, then use a comma to separate the x argument from the y argument, and then put another 0. Then add another comma and type the text that you want to draw to the screen. When using strings, you must put quotation marks before and after it. This tells GameMaker that it is a string. If you don't add the quotation marks, GameMaker will think you are trying to use a variable and you will be given an error if it does not exist. Now that we have our arguments filled in, we can close the code interface by clicking the green tick at the top left. Now we can add our object into an existing or new game room and run. When the game runs, you should see your text being drawn at the top left of the screen. Close the game and reopen the object we just used to draw the text. Add in a create event and drag a code block into it. We just drew text to the screen by typing our text directly into our function. So now let's do it again, but this time using a variable to hold the text we want to draw. In the code block, type str equals, and then the text you want to draw. Remember, a string or text must have quotation marks before and after it, or it will be seen as another variable. Once you have your text written, click the green tick at the top left and reopen the draw event code. Now replace the text you wrote into the function with the variable name, which is str. Make sure you take away the quotation marks as well, or it will consider str to be another string, and this game will simply draw str to the screen. Now run your game again and you should see the string being drawn. In this topic you learned the basics of using a function. You are now one step closer to writing your own code and programming your own game. In the next topic we will cover the if statement. This will allow you to check for things before executing functions. In this section we'll be learning about the if statement in GML. The if statement essentially allows you to ask your game a question. This might be something such as seeing if the player's lives are at 0 or checking to see if a key is pressed. The if statement supplies the main structure of GML code.
Using the if statement is fairly simple. You simply type if beginning the if statement. You then give the program a function or mathematical equation to check. Then you add an opening and closing curly brace between which you type the code to be executed if the statement returns true. Create a new object and then add a step event. Now drag in a code block. We're going to check to see if the player is holding down the right arrow key, and if they are, we will move the object to the right. Before we start, it is important to know what the step event is. The step event is an event that is executed once during every step in your game. By default, your game will run at 30 steps a second. This can be changed if needs be, but for now we will leave it at 30. Now you're probably wondering what a step is. A step is like each frame in an animation. During a step, all the sprites are drawn to the screen and any code in the step event or draw event is executed once. This is then repeated 30 times a second unless you have changed your room speed. With that being said, we are ready to type our if statement. On any line, type if, and then add a space. We are now going to use the keyboard check function to see if the right arrow key is being pressed. So type keyboard check, then add an opening and closing bracket. Now go in between these brackets and you can see that we need to supply a key argument so that it knows which key we want to check. There are multiple ways to type in which key you want to use. The first way is to type the key code. However, if you don't know the key codes, then don't worry. Type VK right. This is a built-in variable that holds the key code for the right arrow key. There are also variables like that for the up, left, and down arrow keys. Simply replace right with left, up, or down. With this typed, we are ready to give our if statement some structure. We need to add an opening and closing curly brace. You don't need to put them on separate lines, but it makes it easier to read later on. The opening and closing curly braces are where we will write our code that needs to be executed when the if statement returns true. If the if statement returns false, then anything inside of the curly braces will be skipped and the code will continue on to the next part. Now we have our if statement set out, we need to give it something to do when it returns true. We want to move the object to the right when the key is pressed, so we need to add a value to the x variable of this object which will move its position to the right. In between the curly braces, type x plus equals 4. Typing x plus equals 4 may be confusing and leave you wondering why it is typed in such a way. Typing x plus equals 4 is the same as typing x equals x plus 4. You are simply adding to the variable's current value instead of completely resetting it. This will move our object 4 pixels to the right while our key is pressed. Remember that this code is being run 30 times a second, which means our object will be moved 120 pixels to the right per second as long as we are holding down the right arrow key. If you want to move the object left, you should subtract 4 from the x variable instead of adding it. This is it for our if statement. As you can see, we start by checking if the key is being pressed. Then if it is, we add 4 to our x value, which moves our object to the right. Tick off the code, then create a simple sprite and add it to the object. Now place your object to the left side of a new or existing room. You may now run your game. If everything goes well, your object should move to the right when holding down the right arrow key. That's it for the if statement. You can put if statements inside other if statements if you want to check more than one thing before executing your code. This will require extra curly braces inside of the curly braces of the first if statement. You will see this as we begin to make the game. In this topic you'll learn about the if statement and how it can be used. You should now have a fair idea of how an if statement is used and be able to set up your own basic checks in GML. In the next topic we will learn about the for and while loops and how they can be used for data checking and input. In this topic we will be learning about the for and while loops. Loops can be used for a variety of things in GML. They are commonly used to do repetitive tasks until a stop condition is met, for example searching through data. The only problem with loops is it's easy to make a mistake and freeze your game. When a loop is executed, it is executed continuously within the one step. So if there is no way out of the loop, then the game will continue to run the loop and get stuck in the step it is currently in. This will cause your game to freeze and you'll have to force close it. It is important to ensure that there is always a way out of a loop. We will start with a while loop.
The while loop is like saying to someone, while this is happening, do this task. So as long as something is or isn't happening, the code will repeat. Create a new object and add a step event, then drag a code block into it. To type a while loop, simply type while. Now we need to give it something to check. We're going to check this object's x value, and as long as it is below 100, we will add 1 to it. So we need to type while x is lower than 100. Then add an opening and closing curly brace. In between the curly braces, write x++. X++ is the same as writing x plus equals 1 or x equals x plus 1. All three ways will add 1 to x. You could also use x minus minus to subtract 1. You may be wondering why it is x plus equals 1 instead of just writing x plus 1. This is because typing x plus 1 will be used when checking if a value is equal to or higher than x plus 1. As seen just before, there are actually 3 ways to add and subtract 1 from a variable. The first and easiest to understand is x equals x plus 1. As you can see that we are setting x to its current value plus 1. So if it was 1, it gets set to 1 plus 1, which equals 2. The next way is to write x plus equals 1. This is a simpler way and can be used on numbers higher than 1 also. The final way is writing x plus plus. This is a shortcut to writing the others. It only adds 1 to a variable. You can't use it to add more than 1. This is it for the while loop. Give the object a sprite and then place it on the left side of a new room. When you run your game, your object should end up at x 100. It will be instant because the loop is run as soon as the object is created and every change in the x value is done in one step. Now we can move on to the for loop. The for loop works generally the same way, but is more commonly used when checking numbers. When typing a for loop, you need to give it 3 arguments. You start by giving it a number to start on, then you give it a number to check, and then you give it a value to add, subtract, multiply, or divide. Type for and then add in an opening and closing bracket. In between the brackets, type I equals 0 and put a semicolon. Then put a space and put I lower than 100, and do another semicolon. Then do another space and write I++. I is a temporary variable created in the first argument. So where we typed I equals 0, we are creating a temporary variable named I. Where we typed I is lower than 100, we are checking to see if I is lower than 100. Finally, where we typed I++, we are adding 1 to I if the loop returns true. So essentially, it's like saying while I is lower than 100, add 1 to I. Once again, we need to add an opening and closing curly brace. In between the curly braces, type x equals I. This will set this object's x value to whatever I equals. So it will start by setting x to 0, then 1, then 2, and so on throughout the loop. Delete the while loop if it's still there and place your object to the left side of the room. Now run your game. It should have the same effect as the while loop. So as you can see, for and while loops are fairly similar. You might be wondering why there is even a need for both. While loops are more practical when using functions to check things, for example running a loop while the spacebar is pressed. For loops are better for when you are just checking numbers, for example running through a large number of objects and changing the variable inside all of them.
In this section you learned how to use a for and while loop. You should now be able to set up your own basic loops. In the next section we will begin to create our own platform game. We will see more loops as we go and we'll begin to get a stronger understanding of GML. In this section you will learn more about sprites and objects. We will cover some of the features that were missed during their basic explanation. In this topic you will learn good practice in naming objects and also be shown the main features within them. To create an object, click the button in the main toolbar shaped like a green ball. The object interface will then show up and we are ready to go. The first thing to do after creating an object is giving it a name. Yes, you can leave it with the default name, but when creating a big game it is nice to have a simple and meaningful name. When naming any resources, it is good practice to start with a code word for the resource type. Personally, I use obj for objects. So with the player object, instead of just naming it player, we name it obj_player. This way, when referencing it in code, we can easily see it is an object. The same goes for all other resource types. For example, your player sprite could be called SPR_player. You will have noticed the 7 tabs on the right side of the object. These tabs contain a number of drag and drop functions that you can use to create your game. You can create entire games using drag and drop functions, but to achieve more and a more professional look and feel to your game, it is a good idea to learn GML. Remember that drag and drop functions are written in GML, so anything you can do in drag and drop can be done in plain GML as well.
Another thing you may have noticed is the Add Event button. There are a number of events that can be used in GameMaker. These range from the simple and common create event to things like key presses and mouse checks. Again, a lot of functions can be done using an if statement in GML. Beneath the sprite section of your box, you can see 4 checkboxes labeled visible, solid, persistent, and physics. The visible checkbox enables and disables the draw event of an object, making it invisible when the game is played. The solid checkbox is used to tell GameMaker that you want the object to be treated as solid. This does not change much within the object. There are some functions that work with solid objects only. If making an object solid, that object shouldn't move during your game. The persistent checkbox is used to toggle whether or not an object is persistent throughout all rooms or not. If it is checked, your object will stay in every room of your game from the point of its creation until you destroy it. Finally, the physics checkbox enables or disables physics. The physics in GameMaker Studio is powered by the Box 2D physics engine. We will not be using it during this course. Beneath the checkboxes you can see a text box labeled depth. This is used to set the depth of an object. The depth is the order of which objects are layered in a room. If set to 0, GameMaker will handle depth automatically by using the creation order. The higher the depth number, the lower your object will be. So an object with a depth of 1 or higher will show below an object with a depth of 0 or lower. Finally, you can see the parent and mask buttons. The parent button allows you to set a parent object for the current object. This is useful when grouping objects of similar types together. We see this used for the collisions during the creation of our platform game. The mask button allows you to set a collision mask for your objects using a sprite. In this topic you learn about the extra features in the object interface and how they can be used. You should now have a good understanding of the features available in objects and their general use. In the next topic we will learn more about sprites and the right way to set them out and make designing your game easy. In this topic we will learn good practice when using sprites. Sprites are fairly simple, but there are some tips for when using them. For example, choosing the right size for your game and when to use 2 sprites instead of 1. To start with, let's make a new sprite by clicking the green Pac-Man shaped button in the main toolbar. This sprite should be named the same way that was described in the last topic, using SPR_ for a keyword to signify that it is indeed a sprite. You don't have to use that keyword, but it is simple to understand and is globally recognized. Name the sprite SPR ball. It is always a good idea to use keywords as they help to define resource types when typing them in GML. This makes it easier to tell that this resource is a sprite when just looking at its name. Now that we have named it, click Edit and we will begin to create our sprite. When the editor comes up, go to File and then New. This will show a dialog box where we can enter the size of our sprite in pixels. It is advised that you keep your sprite sizes at a power of 2, for example 32, 64, 128, etc. This makes it easier to place your sprites on a grid without overlapping and becoming complicated. The default sprite size is 32 by 32. Remember that sprites are bitmap images, so if you plan to have zooming in your game you will need to have bigger, higher quality sprites to avoid pixelation. Leave your sprite at 32 by 32 and click OK. Sprites can be both imported from an external file or drawn directly in GameMaker. In this case we are going to draw it. Double-click on the empty sprite and draw a ball by using the circle tool and dragging from the top right pixel to the bottom left pixel. This ensures that our ball is exactly 32 by 32 pixels. With our ball drawn, click the green tick at the top left of the editor. Then click the green tick on the sprite creation window to close them and save your sprite. Every sprite has its own collision shape so that GameMaker can handle collisions between objects. By default, the shape is a rectangle at the same dimension as the sprite. To edit the shape, click Modify Mask. This will show a new window where you can edit the collision mask for your sprite. Set the collision shape to ellipse, and then click OK. This will change our collision shape to a circle and you should see Modified in red text just above the Modify Mask button. Finally, we can change the X and Y origin of the sprite. The origin is used to position your sprite on the grid in the room editor. By default, it is in the top left corner of your sprite. You can change it by clicking on the sprite preview, or you can enter it manually in the text boxes provided. Click on the button that says Center. This will set your X and Y origin to the center of the sprite. Click OK to save this sprite. We are now ready to attach our sprite to an object. To do this, create an object and name the object obj person. Click the button to the right of the sprite text box and choose the sprite we just created. You can also assign sprites through GML code. To do this, set the sprite for this object to noSprite. Now add a create event. Drag and drop a code block into the create event. Now type sprite_index equals and then the name of our sprite, which is spr_ball. Sprite index is a built-in variable that holds the ID of the sprite being used for the object. We can change the sprite of any object by changing its sprite index. Press the green tick and add the object to a new room. As you can see, when putting it in the room, the sprite isn't shown, and instead it shows a default sprite of a blue ball with a question mark on it. Run your game. As you can see, when in-game, the sprite shows as normal. This is because we set the sprite index in the create event of the object. Close the game and delete the object in the room. Now reopen the object and go to the create event. Delete the code in the create event and then delete the create event as well. Now go back to the sprite and set the sprite to SPR_ball again. Hit OK and put the sprite back in your room. As you can see, with the sprite attached to the object shows the sprite that we selected in the room as well. The sprite is now ready to be used in a game. In this topic you learned the good practices of naming and sizing a sprite. You also learned about collision shapes and the origin of sprites. You now have the required knowledge to make designing your game simple and efficient. In the next section we will be learning about basic animation. In this section we will be learning about animation. Animation is extremely common in games and adds life to things such as running and jumping. In this topic we will learn how to create an animated sprite. To start with, let's create a new sprite and call it SPR_ball_shrink. Once named, click the Edit Sprite button and we can get to work. Go to File, New, and then click OK on the dialog box. Then double click on the blank image to open it and edit it. To zoom in, scroll your mouse wheel up. Draw a circle from the top left pixel to the bottom right pixel, and click the green tick to save it. There are two ways we could go about making this ball shrink. The first is to add in another blank image to the sprite and draw a slightly smaller ball, and then repeat this until it shrinks enough. The second is to use one of GameMaker Studio's inbuilt animations. GameMaker Studio has a few inbuilt animations that you can apply to your sprites. These include things such as grow, shrink, and disappear. In this case, we will be using shrink. Go to Animation, Shrink, and Center. This will show a dialog box asking how many frames you want to use during the animation. The more frames, the smoother and more gradual the shrink will be. Type 20 into this dialog box and click OK. This will generate the animation for the ball shrinking. As you can see, an animated sprite is nothing but a couple different sprite images added into one. You can preview the animation on the left of the sprite interface by clicking Show Preview. Click on the green tick to save our animated sprite and take us back to the main sprite interface. Now click Modify Mask. In this interface you can see the collision mask for this sprite. At the moment, the collision sprite is based off the first sprite only. So if the animation is near its end and the ball is small, any object that touches it will still react as if the ball was big. To solve this issue, set the collision shape to precise and then click Separate Collision Masks. This will allow you to have a separate collision mask for each frame in the animation, meaning objects will collide with whatever frame is visible in each step. You can then edit the collision mask further if you want, but it is not necessary for this topic. Click OK to save this. Make sure you save this project as it will be used in the next topic. You now know how to create an animation and change its collision mask. You can now use these skills to add more life and movement to your GameMaker games. In the next topic we will learn how to further control our sprite's animation. Make sure to save this project as it will be used during the next topic also. In this topic we will learn to further control an animated sprite using GameMaker language. This topic will continue directly from the previous topic and we will be using the sprite we have already made. With our animation already made, we can now link our sprite to an object ready for use in our game. Create a new object and call it OBJ_ball_shrink. Then give it our sprite. Now create a room by clicking the white form icon in the main toolbar, and add the object to it so it is visible when the game runs. Now click 1 to see the sprite in action. You should see the sprite running its animation when it runs. What if we want to make the animation slower, faster, or even stop? There is one inbuilt variable that allows us to do all three things easily. Close the game and go back to the object. Add in a create event and then drag in a code block. Now type image_speed. The image speed variable is an inbuilt variable for all objects. It allows us to set the animation speed for our sprite. Every object has its own image speed variable. By default, it is set to 1. That means every step the animation will progress by 1 frame. To slow it down, we can set it to 0.5. This means it will take 2 steps to run through 1 frame. Or we can make it even slower and set it to something like 0.1. Remember, the slower the animation is, the more jumpy it will look. Type in =0.5. Now run your game. It is not necessary to close the code interface. You should now see the animation running at half the speed it did in the previous run. You can make the animation run faster by setting it to something like 2. This will make the animation run 2 frames every step. To stop the animation completely, set image speed to 0. This means 0 frames each step, which means there will be no animation. Experiment with this to see its effects. You now know how to create an animation, change its collision mask, and how to change its animation speed. These skills allow you to add more life and movement into your games. In the next topic we will learn about movement and object interaction. In this section we will be learning about movement and object interaction. In this topic we will be learning how to create simple movement. This will give us a good starting point for more advanced movement. To start with, create a new object and name it obj_player. This will be the object that we are moving and playing as. Now add a create event and drag in a code block. The first thing we are going to do is initialize a few variables for our controls and speed. The first thing we will do is speed. Type spd equals 8. The spd stands for speed, and we are setting it to 8. You may be wondering why we don't just write speed instead of spd. In GameMaker, there are a number of constant variables which are built in and always exist in each object. These variables simplify things such as movement. Setting speed to 1 would make the object move 1 pixel in a direction based off the direction variable, which is also constant. When reading about GameMaker, these variables are often referred to as constants. Now go to a new line and type right equals vk right. This creates a variable called right and assigns it the right arrow key's key code. We will then use this variable to reference the key we want to use in our code later. Now we need to do the same for up, left, and down. So up equals vk up, left equals vk left, and down equals vk down. We are now ready to program our movement. Tick off the code and add a step event to the object. Now drag in a code block. We will now type our movement code. To do this, we will be using a series of if statements to check if a key is being pressed. If it is, we will then move our object accordingly. Type if keyboard_check, then 2 brackets, and then in between those brackets put our variable right. This will check for our right key, which is set in the create event. Now we need to add curly braces. Inside them, type x plus equals speed, or spd in this case. This will add 8 to our current x position and move the object right. We pretty much just need to repeat this for the next 3 directions, except for up and down we use y instead of x. Copy and paste that code 1 line below. Now in between the new curly braces you can see where it says x plus equals speed. Change it from x plus equals speed to x minus equals speed. You would have seen in your math classes that positive x points to the right and negative x points to the left. This works the same way, so we subtract to go left. So now we do essentially the same thing for up and down using y. Down is positive and up is negative. Don't forget to change our variable to left instead of right. Feel free to copy those 2 lines of code and then paste them 1 line below. Change the first variable to down, and then change x to y. Remember that adding to y will make the object go down. Now below that, change left to up, and then x to y again. Subtracting from y makes the object go up. That is it for our code. Give the object a sprite. and then create a new room and add the object to the room. Now run your game and use the arrow keys. If all goes well, the object should move according to the keys that you press. Close your game and bring the create event up in the player object. The reason we use variables to hold our key values is because this makes the code easier to edit later on. Say you wanted to change the keys to work with W, S, A, and D instead of the arrow keys. You would need to search through your code and find the places where the key checks are being done. Doing it through variables eliminates the need to search through your code. Instead, you can just change the variable values in the create event. Let's try this now. Change VK_right to ORD D. Make sure it's a capital D and that it's in between quotation marks to show that it's a string. Next, go to VK_up and change that to ORD W. For left, change it to ORD A. And then for down, change it to ORD S. The ORD or ORD function stands for ordinary key. It simply returns the key code for whatever letter you enter as an argument. The letter must be a capital and must be a string. Remember, strings are defined by quotation marks. Run your game again and use W, S, A, and D to move. If all has gone well, your object should move around the screen accordingly. That's it for this video. We learned how to use variables to store key codes, making it easier to change them later on, and we learned how to check to see if a key is being pressed and move an object accordingly. We also learned about the X and Y axis. In the next topic, we will learn about object collisions and interactions. In this topic, we will be learning about object collisions and interactions. Collisions are extremely common in GameMaker and are used in most games. They allow for objects to perform actions when they collide with something. Create a new object and call it obj_bullet. Now create another new object and call it obj_enemy. Now create a new sprite and give it a small circle shape. 8 by 8 pixels will work best. Open that and draw a circle inside of it. Now tick off the sprite editor, center it, and hit OK. Now create another new sprite and call it SVR_enemy. Give it another circle shape, but this time 32 by 32 pixels. Center that as well and hit OK. Now attach the sprites to the relevant objects. So SPR_bullet goes to OBJ_bullet. Now SPR_enemy goes to OBJ_enemy. We are now ready to go. To start with, let's get our bullet moving when we press space. Go into the bullet object and add a step event. Now drag in a code block. Type if keyboard check released, then add the opening and closing brackets. In between those brackets, type VK_space. This is our space on the keyboard. Now add the curly braces, and in between those, type speed equals 8. This will make our bullet move right at a speed of 8 pixels a second when we release space. You might be wondering why the object will move right. This is because the object's current direction is set to 0. 0 is right, 90 is up, 180 is left, and 270 is down. The direction can be changed by setting the direction variable that is inbuilt to all objects. Now we have our bullet moving, let's make something happen when it hits the enemy. Tick off the step event code and add a collision event with the enemy object. Then drag in a code block. Type instance destroy and put an opening and closing bracket on the end, as this is a function. This will destroy this object when it hits the enemy, so the bullet will be destroyed, not the enemy. Tick off the code and then tick off the object. Create a new room or use an existing one if you've already got one. Add the enemy object on the right side of the room, and then in line with that, put a bullet object. This way, when we press space, the bullet would move to the right and hit the enemy object. Run the game, and when it shows, press space. The bullet should move to the right and be destroyed when it hits the enemy. That's it for this video. You should now be able to create collisions between objects. In the next topic, we will be looking at buttons and changing levels. This will allow us to dive deeper into object interaction. In this topic, we will be learning about buttons and changing rooms. Buttons are a very common thing in games. In most cases, they're used in game menus. We will be creating a button that changes the room. This allows us to use one room for the menu and another room for the actual game. Let's start with creating two rooms. Click the Create Room button and then click it again to make a second room. Then change the color of the background in the second room to red. This way we will know when the room has changed. Tick off both rooms. Now create a sprite called SPR_button. Hit Edit Sprite and then go File, New. Set the size to 64 by 64 and click OK. Now open up the sprite and just draw a square. Tick off the sprite and tick off the editor, and then center it, and hit OK. Centering the sprite isn't essential, but it can make it easier when positioning it in the room. Now create an object called OBJ_button and give it the same sprite. Now we can get on to making our button change rooms. In the object, add a left press event and then drag in a code block. Type room, go to, next, and then put on the opening and closing brackets. This function takes us to the next room. However, if we were to put this button in the last room and the player was to click it, the game will give an error because there is no room to go to. You can also change directly to a room of your choice. For this, type room, go to, and then in between the brackets type the room name. In this case, we only need to use room go to next. With the code typed out, tick off the code and then tick off the object, then bring up the first room. Now add the object anywhere inside of this room, and then run your game. If all goes well, you should see the button. When you click the button, it should take you to the second room that we created with a red background. This is about it. If you ever want to go back to the previous room, just type room_go_to_previous. This is the exact opposite of room go to next. With that being said, we are all done. You should now be able to change rooms through GML and create simple buttons for your games. Remember that these buttons can do other things apart from changing rooms. It's all up to how you program it. In the next section, we will learn how to create advanced movement and begin the creation of our platformer game. In this section, we will begin creating advanced movement for our platforming game. All the code will be explained as it is written, and it should be easy enough to understand if you have watched the previous topics. In this topic, we will begin by setting up the required variables for use in the game. These variables will provide the main stats for the player object and allow us to edit things easily later on. To begin, create a new object and name it OBJPlayer. Remember, GML is case sensitive, so if you use a capital, you will need to use that in the code as well. Now add a create event and drag in a code block. With the object set up, we are ready to begin typing our variables. We will start with variables to store our controls. We would need 3 variables for this, one for jumping, one for left, and one for right. Simply type key_right equals vk right, key_left equals vk left, and key_jump equals vk space. This initializes our variables and they are ready for use later. Now we can move on to the player stats. The stats will include speed, maximum speed, acceleration, deceleration, jump power, and gravity power. We should simplify these names to make things easier later on though. Type stat SPD equals 0. This variable holds the player's current speed. We don't want the player to move when it's first created, so we set this to 0. Next, type stat_max_SPD equals 8. This holds our maximum speed in pixels. We don't want the player to speed off out of the game room, so we limit the speed they can move. Next, type stat accel equals 1. Then on a new line, type stat decel equals 1. These variables hold our acceleration and deceleration values. When a key is pressed, the player's current speed will be affected by these values. When it comes to optimizing the game, it would be best to only use one variable as both hold the same value. The reason we have created 2 variables is so that it is easier to edit later on. Should we want the player to slow down over a longer period of time, we can lower the stat decel variable. The final 2 are stat_jmp for jump, and we'll set that to 10. And then stat_grav or grav, which stands for gravity, and we'll set that to 1. The first variable holds our jump power. We will use it to send our player flying into the air when the jump key is pressed. The second variable is for our gravity power. While the player is in the air, this value will be added to the player's vertical speed, which will eventually pull them back down to the ground. That's it for the variables we need. We are now ready to type out our code for the movement itself. You should now have a good idea of all the variables involved and what they are used for. In the next topic, we will move on to typing our movement code. In this video, we will be typing our movement code for the player object. This is following directly from the last video, and we will be using the variables created in that video to control our player. So far, we have been using fairly simple code. This is going to be a lot more in-depth and will combine nearly everything we have learned in previous sections. To start with, we need to create two ground objects. Call one obj ground, and create another one and call that one obj underscore ground underscore parent. The ground parent will be used to group out ground objects together. This allows us to reduce the number of collision events we need to have in the player object. There are two reasons we want less collision events in the player object. The first is for optimization. The less separate events, the less the game needs to do in order to keep track of such events. The second reason is it makes it easier to keep track of the object on the developer's side. There is less events to read through should a problem arise. Always try to be smart with parenting objects. Run the parent objects that are similar, otherwise things may become difficult later on. In obj ground, tick the solid box. Then set the parent as obj ground parent. Once these are made, bring up the player object, add a step event, and then drag in a code block. We are now ready to start typing our movement code. We will start with gravity. Every platformer needs gravity, otherwise the purpose of jumping is defeated. Gravity works by checking the space directly below the player to see if there is a free position or not. If it is free, then we need to set our gravity to statGrav, which is a variable we created in the previous topic. If the space isn't free, then we set the gravity to 0. Type if place underscore free opening bracket x y plus 1 closing bracket. Then add our curly braces. In between our curly braces, type gravity equals stat underscore grav. This will set our gravity to 1. Gravity is a built-in variable for every object. Now we need to make it set the gravity to 0 when the place isn't free. On the next line, type else. Else is used to give an if statement more structure. It allows you to perform a separate action if a statement returns false. It works a lot like the if statement. Add curly braces to contain the code to be executed. Inside these curly braces, type gravity equals 0. You will have noticed the way I've been tabbing out the lines of code in between the curly braces. The reason for this is it makes it easier to keep track of what code is in what curly brace. So as you can see, each statement starts on one line, and then its curly braces are contained on that same line. To check exactly which curly braces match up with each other, highlight one of the curly braces, and then the other one will also be highlighted with it. That's it for our gravity. Now we can move on to our actual movement. Return down 2 lines. Our object is going to move based off the stat speed variable. We will add and subtract to this to give our object some speed. To make this happen, we need to check for keys pressed. Then we need to check to make sure that our speed is not going to go above our maximum speed if we add to it. If it isn't, then we are free to apply our acceleration variable. Type if keyboard underscore check opening bracket key underscore right closing bracket, and then add in some curly braces. In between these curly braces, we're going to use another if statement. Type if stat underscore spd is lower than stat underscore max underscore spd. Then add in another set of curly braces for that statement. Then in between those curly braces, type stat underscore spd plus equals stat underscore accel. You can see better here the way tabbing out the lines of code makes things more organized. You can tell that this if statement is matched up with this curly brace, as they are both on the same line when tabbed out. Anything inside the if statements gets tabbed out one line. It simply makes it easier to read later on. It isn't completely necessary to make things work. This code starts by checking our key. It then checks the speed against our maximum speed. and then applies the acceleration we need. It's generally the same for the left key, the only difference is we're checking the speed in the opposite direction and subtracting our acceleration value. Copy the code we just typed, and then paste it one line below. Then change key right to key left. Change the second if statement from if stat underscore spd is lower than stat max speed to if stat underscore spd is higher than minus stat max speed. Then change the code in between these brackets to stat spd minus equals stat accel. As you can see, we are subtracting our acceleration instead of adding to it, and checking to see if our current speed is higher than negative max speed. That's it for applying our speed. Now we need to make this affect the player's position in the room. Return down another 2 lines. This is where it gets more complicated. We want our player to be able to move up slopes if we add them to the game. To be able to do this, we need to use loops to check the position above us until we find a place that is free and that we can move our player to. We start by checking to see if the current speed is higher or lower than 0, meaning that we are supposed to be moving. Then we set a temporary variable to our current speed, and use that in the loop to check for a free position. We then use a while loop to check if our temporary variable is higher than 0. If it is, we begin the loop. Inside the loop, we check for a free position in front of us using the temporary variable we have set. If the place in front of us is free, we can move forward and break the loop. If the place isn't free, then we subtract from a temporary variable and run the loop again. Type if stat underscore spd is lower than or higher than 0, and add in a set of curly braces. In between these curly braces, type var s equals stat underscore spd. Then on a new line, type while s is higher than 0, and add another set of curly braces. In between those curly braces, type if place underscore free, then add an opening bracket. Now type x plus s for the x variable, and then y. Then add a closing bracket and add another set of curly braces. In between our new set of curly braces, type x plus equals s. And on a new line, type break. Now after our place free set of curly braces, put a new line and type s minus minus. This ensures that our temporary s variable is at some point lower or equal to 0. You may be wondering why we are using a loop and not just adding to the speed normally. We are using the loop because it allows us to get pixel-perfect collisions with walls, whereas doing it the easy way may result in player colliding with a wall a few pixels away. The loop makes it so we can start by checking the normal distance away, and if that doesn't work, we can check all positions from the furthest point back to our player and move accordingly. Once again, it's pretty much the same for going left. We just check for a speed lower than 0 and subtract our speed from x instead of adding to it. Copy the code in between the stat speed check, and then paste it one line below. We can delete the var s equals stat speed for the second set of code only, as it is already set up the top and becomes unnecessary at that point. Now change while s is higher than 0 to while s is lower than 0. Then change s minus minus to s plus plus. This allows us to move right and left horizontally, but we still can't go up slopes because once a position isn't free, we simply stop. To check for a slope, we're going to use another while loop. We start by setting a temporary variable to 0. This is our starting height relative to our player's y value. We then check if I is lower than 12, which is our maximum height. We need a maximum height for 2 reasons. The first is so that the loop has an exit, and the second is so that we don't move up and above walls that we shouldn't be able to step up. Next we check if the place is free at the player's x plus its current speed, and the player's y minus our temporary variable. If it is free, we move up by our temporary variable's value. Then we check to see if our temporary variable's value is higher than 0. If it is, we move along the x-axis at the current speed, and we end the loop. If the place isn't free, we add 1 to our temporary variable and we repeat the loop. Beneath the code we just wrote, and inside the stat speed check, type var I equals 0. Now type while I is lower than 12. In this case, 12 is our maximum height that we can move up in each step. Then add an opening and closing curly brace. Now type if place underscore free and add an opening bracket. For the x argument, type x plus stat underscore spd, and for the y argument, type y minus I, and then put a closing bracket and add another set of curly braces. Type y minus equals I. Now beneath that, type if I is higher than 0, and add another set of curly braces. In between these new set of curly braces, type x plus equals stat underscore spd. Now beneath the if I is higher than 0 check, add a new line and type break. This ends the loop. Now beneath the closing bracket for the if place free check, we need to add a new line and type I++. That is it for making a player move, but in the player's current state it will move and never slow down or stop on its own. We need to apply friction. This again will be using while loops, which you should be fairly familiar with now. We start by making sure we aren't holding down our right or left key. We don't want to apply friction when the player is trying to move. Then we check if our player's speed is higher than 0. We then set a temporary variable to our deceleration variable. Then while the current speed is higher than 0, we check if the current speed minus the temporary variable is higher or equal to 0. If it is, we subtract a temporary variable's value from our current speed and end the loop. If not, we subtract 1 from our temporary variable and repeat the loop. Type if not keyboard underscore check, opening bracket, key, right, closing bracket, and not keyboard underscore check, opening bracket, key, left, closing bracket, then add in curly braces. In between these curly braces, type if stat underscore spd is higher than 0, and add in another set of curly braces. Now in between those, type var I equals stat decel. Beneath that, type while stat underscore spd is higher than 0, then add in another set of curly braces. In between those, type if stat underscore spd minus I is higher or equal to 0, and add in another set of curly braces. In between those, type stat underscore spd minus equals I. And then beneath that, type break. Then move down one line from that final curly brace. Now move down one line from the closing curly brace in the while loop and type I minus minus. Now we need to do the same thing for when the player's speed is lower than 0. We just subtract instead of adding. Copy the code in between our keyboard checks. Then paste it one line below. Change if stat speed is higher than 0 to if stat speed is lower than 0. Where the while loop starts, change higher than to lower than. Then inside of that, change if stat speed minus I is higher than or equal to 0 to if stat speed plus I is lower or equal to 0. Then change stat speed minus equals I to stat speed plus equals I. Now we need to make our player jump. It isn't much of a platformer if we can't jump onto other platforms. This is fairly simple. We start by checking to see if a jump key is pressed. Then we check to see if we are on the ground or not. If both are true, then we set our vertical speed to negative stat jump. Type if keyboard underscore check, opening bracket, key, jump, closing bracket. Now type and place underscore meeting, opening bracket, x, y plus 1, obj underscore ground underscore parent, add a closing bracket, and then add in a set of curly braces. In between those curly braces, type vspeed equals minus stat underscore jmp. So now when we press the jump key, the game will check to see if we are on the ground or not, and if we are, we will jump. Finally, we need to give our ground and player a sprite. Create a new sprite and call it SPR ground. Then just make a 32 by 32 pixel square. Center this sprite. Now create another new sprite and name it SPR player. Make this a 32 by 32 circle.
center the sprite and turn on precise collision checking. Now link the sprites to the designated objects. SPR ground goes to OBJ ground, and SPR player goes to OBJ player. In the player object, add a collision event with OBJ ground parent, and then drag in a code block. Because OBJ ground is parented to this object, the collision will also apply to OBJ ground. In the code block, type move_contact_solid, and add an opening and closing bracket. In between these brackets, type direction, comma, and then 8. Now in a new line, type vSpeed equals 0. In the code, we start by moving our player into contact with the ground when it is within 4 pixels of a perfect collision. This distance can be raised if your object appears to bounce when it collides with the ground. Next, we set our player's vertical speed to 0 to ensure that it doesn't continue falling through the ground. That's it for our movement. As you'll have seen, it's a lot more in-depth and complicated than normal, but you have a smoother and nicer looking movement system as a result. You should now know how to use a while loop, use if statements, and use variables comfortably in your code. In the next video, we'll move on to sprite control. In this video, we will learn about sprite control. Sprite control can be fairly complex when working on large games with a lot of animations. However, for this, we will just be making the character face the direction it is moving. Start by opening your player object and going into the create event code. Beneath all the variables, type DRI equals 1. This stands for direction. We will be using this to keep track of which direction the player is moving and to scale our sprite accordingly. For actually facing the sprite in the direction, we will simply be scaling it along the x-axis. A scale of -1 will flip the sprite in reverse, whereas a scale of 1 will draw it normally. Tick off the create event code and open up the step event code. Beneath if keyboard check right, between the curly braces, type dir equals 1. This will set our direction variable to 1 when we press the right arrow key. Do the same beneath the left key check, but set it to -1 instead. Tick off the code and bring up the player sprite. Now click on Edit Sprite and double-click on the sprite. We need to add a line to the right side of the circle as a symbol that this is the front of the sprite. You could also add a face to it if you wanted, but for this we will just add a line. Save the sprite and reopen the player object. Add a draw event to the player object, and drag in a code block. When you add a normal draw event, the automatic drawing of the object is disabled. So if we were to add an empty code block to this event and run the game, you wouldn't be able to see the object. We are going to manually draw our sprite. Remember, the draw event is used for drawing things to the screen, for example sprites or text. The draw event runs once every step. A step is basically a frame or subimage in the game. Type draw_sprite_ext, which stands for extra. Then add an opening and closing bracket. This function allows us to draw a sprite to the screen and apply scale, color, and rotation to it. We will only be using it for the scale though. In between the brackets, type sprite_index, then a comma, image_index, another comma, type x, another comma, y, another comma, dir, which is our direction variable that we just created, then 1, 0, c_white, and 1 again. Sprite index is a built-in variable that holds the index of the sprite linked to this object. Image index is the current frame in the sprite being used. X and Y are simply the position of this object. dir is applied to the x scale of the sprite, making it flip as the variable changes. Y scale is set to the default 1. We set rot to 0 so there is no rotation applied. We set the color to see white, which is simply a built-in color variable. And finally, we set the alpha to 1 so there is no transparency. If you now create a small level and run your game, you should see your sprite swap directions as you press the arrow keys. That's it for this topic. You should now have a good idea of what sprite control is and how it can be done. In the next section, we will begin implementing gameplay features. In section 7, we will be looking at giving our platformer game an objective and adding gameplay elements. In this video, we will be creating a goal for our game. Then we will create objects that the player must collect to finish the level. To start with, let's make a sprite for the goal. Create a new sprite and call it SPR_goal. Now click Edit Sprite and create a 32 by 32 green circle. You can change the sprites to look better if you want, but for the purpose of this tutorial we will keep things simple. We now need a second sprite for our collectible objects. Create another new sprite and name it SPR_collect. Create a simple 16 by 16 yellow circle. With our sprites created, we are ready to make some objects. Create a new object and name it obj_collect. Give it the sprite we created earlier and click OK. Now create another object and name it obj_goal and give it the sprite that we created earlier as well. We're going to make our goal object check to see if all the collectible objects have been collected. To do this, we will check the number of collectible objects, and if it is lower than 1, we will show a message saying that the level has been completed. First, add a collision event with the player object. Now add a code block to this event. Type if instance_number, then add an opening and closing bracket to the end. In between the brackets, type obj_collect, which is the name of the object we just created. Now type lower than 1. This if statement checks the number of the instances that you choose. In this case, we want to check the collectible objects, so for the argument we simply type the object name. Now add curly braces, and in between them type show_message, and then add another 2 brackets to the end. In the brackets, type level complete. Remember to put quotation marks on either side of the message to ensure that the message is a string. Without the quotation marks, GameMaker will think you're trying to use a variable and you will be shown an error when the collision occurs. Beneath the show message, type game_restart and then add an opening and closing bracket to the end. This function simply restarts the game. So now when the goal picks up on a collision with the player, it will check the number of collectible objects. If there are none left in the room, then it will show a message to the player and restart the game. The last thing we need to do is make the collectible objects get destroyed when they collide with the player. Tick off the code and then tick OK on the obj goal object. Now bring up obj_collect and add a collision event with the player. Drag a code block into this event. Inside the code block, type instance_destroy, then add an opening and closing bracket to the end of it. This will destroy the object when it collides with the player. So as you can see, we aren't really collecting the objects, we simply destroy them and make it look like we are. Tick off the code and the object, and bring up the room. Add a goal and some of these objects somewhere in the room so that you can test the game. We can now run and test our game. When you collide with a collectible object, it should be destroyed. Once they are all gone, you should be able to go to your goal object and finish the level. You shouldn't be able to finish the level unless all the collectible objects have been collected. It's always important to think about your level design. While it's fine to make small levels for testing purposes, if you're creating the actual game level, you need to think about what the player is doing, thinking, and feeling. In this case, the game is fairly simple, so your options are limited. However, thinking about things such as the position of the collectibles and the way the platforms are set up are very important, as those create the main gameplay concept of this game. If it's too easy, the player will get bored. If it's too hard, the player may give up. This course doesn't focus on game design, but it is always important to think about these things when creating the games. There are 2 main design concepts that you should keep in mind. The first is the game's interest curve. It may seem like your game should start slow and gradually engage the player more and more and have a big ending, however this often doesn't work. It is often better to have highs and lows within the game. The second is kind versus difference. This is a technique used to give the player mixed emotions and feelings when playing. For example, having different kinds of enemies or different gameplay situations to excite and engage the player. We will not go into detail with these techniques in this course, but once again they are good concepts to learn and remember. That's it. We now have a simple goal for our game. You should now have a good idea on how to create collectible objects and simple goals for your games. In the next video, we'll be looking at creating obstacles and player deaths. In this video, we'll be learning about obstacles and creating a simple death. We will create sparks that kill our player when the object touches them. To start with, let's make two new sprites. Create one and call it SPR Spike. Make a 16 by 16 triangle. And turn on precise collision checking. Now instead of creating a new sprite, right-click the existing player sprite and click Duplicate. This will create a copy of the sprite with a different name. The new sprite will open automatically once you duplicate it. Rename it to SPR underscore player underscore death. We're going to animate the sprite to make it shrink and disappear. Click Edit Sprite. Now go to Animation, Shrink, Center. Type 20 for the frame amount and hit OK. Now tick off the sprite and we are done. Don't forget to center this sprite to make it match up with the other player sprite. With our sprites created, we now need to make corresponding objects. Create a new object, name it obj underscore spike. Give it the spike sprite and click OK. Now create another object, name it obj underscore player underscore death. Give it the player death sprite and click OK. To start with, we will make the player die when colliding with a spike. Open the player object and add a collision event with the spike object. Add a code block and type instance underscore create, then add an opening and closing bracket to the end of it. In between the brackets, type x, y, obj underscore player underscore death, which is the object we just created for the player's death. This will create our death object in the player's current position. Now add a new line and type instance underscore destroy. This will destroy the player object and the death object will be left in its place. Tick off the code and bring up the death object. Click Add Event, Other, and Animation End. Now add a code block into this event. This event will be triggered when the animation for this object has ended, so when our ball shrinks and disappears, this event will be triggered. Type game underscore restart and add an opening and closing bracket to the end as this is a function. This will restart the game when the animation ends. Tick off the code and then tick off any objects that you have open. Open the room that you should already have created if you've watched the other videos and add a few spikes into it. Due to the spike sprites being a smaller dimension to the other sprites, they won't fit on the ground properly and it'll make them look weird when trying to place them on the ground. This is because the objects are being placed based on the grid you can see in the room. To change the size of the grid, go up to where it says Snap X and Snap Y. At the moment both should say 32. Change the values to 8 and 8, and you should now be able to place your spikes perfectly on the ground. Add them to the room and run the game. Make the player object collide with the spikes and it should shrink and the game should restart. If you find that it shrinks too fast, simply change the image speed variable by adding a create event to the death object and typing image underscore speed equals and then the value you wish to give it. To make it shrink slower, you will need to make the value lower than 1, but higher than 0. Something like 0.5 should work. If you don't want to do it this way, you could also add extra frames to the sprite's animation. You would have noticed that the sprite object is essentially empty. There is no code or actions that it performs. This may happen when creating games, and it's okay. What this blank object does is supply the player object with something to collide with, and also give us a way to actually place the spikes in the room. Don't go thinking an object must have a sprite either. It is common to have objects within games that aren't visible to the player. Things such as enemy creators may be invisible but still have a major role in the final game. That's it for creating an obstacle and a simple death. You should now have a good understanding of how you can create a simple death and how simply colliding with another object can be used to kill the player. In the next video, we will look at creating enemies. In this topic, we will be creating simple enemies for our game. Enemies make games more fun and add new challenges for the player to overcome. To start with, we need a new sprite for the enemy. Create a new sprite and name it SPR underscore enemy. Click Edit Sprite and create a simple 32 by 32 red circle. Center the sprite and turn on precise collision checking. Now click OK. Now we need another sprite that we'll use to block the enemies. Create a new sprite, name it SPR underscore blocker. Make it a simple green, transparent 32 by 32 square. Center the sprite and press OK to save it. Now we can create our objects. Create a new object and name it obj_blocker. Give it the blocker sprite and hit OK. Now create another sprite, name it obj_enemy. Give it the enemy sprite and then add a create event to it. Now drag a code block into this event. Type spd equals 4. We will use this variable to set the enemy's speed. Add a new line and type dir equals 1. This variable will be used to change the object's moving direction. Tick off the create event code and now add a step event and drag a code block into it. Type if dir equals 1. This checks our variable dir to see if it is equal to 1 or not. If it is, we want to move to the right. Add in some curly braces and type x plus equals spd. Now on a new line, type else and then add in another set of curly braces. In between them, type x minus equals spd. Now it will check the direction. If it is equal to 1, it will move right. If it isn't, then it will move left. Now we need to make it change direction when it collides with the blocker. Tick off the code and add a collision event with the blocker object. Now drag a code block into it. Type if dir equals 1, then add a set of curly braces. In between those, type dir equals 0. Now in a new line, type else, and then another set of curly braces, then in between those, dir equals 1. This checks the current direction, and if it equals 1, it is changed to 0. If not, it is changed to 1. Tick off the code and tick off the object. Now bring up your room. Put the enemy somewhere in your level. Now add 2 blockers either side of it. The enemy will move from side to side between these blockers. Run your game, and if all goes well, you should see the enemy move between the blockers. You won't want an ugly square showing up in your game, so we should make the blocker invisible to the player. To do this, close the game and bring up the blocker object. Now uncheck the visible option to the left of the object interface. Click OK on the object and run your game again. As you can see, the squares are no longer visible, but the enemy still collides with them. Close your game. Right now, the player can collide with the enemies and nothing will happen. To make the player die, simply open up the player object. Now duplicate the collision event with the spike and make it a collision event with the enemy instead. Run your game again and make the player collide with the enemy. If all goes well, your player should collide with the enemy and the game should restart. That's it for making a simple enemy. You should now have a good idea of how to make an object move between 2 points. This technique can also be used on moving platforms. You should also now know how to duplicate an event and make an object invisible to the player. In the next video, we will look at creating lives and scores. In this topic, we will be adding a health and score system to our game. Having a health system allows the player to get away with a few hits before dying, making things a little easier for them. A score allows for things such as in-game shops. Players can use their score to purchase new items and power-ups. They can also challenge other people playing the game, which adds for extra entertainment value. We will use our player object to keep track of both the score and the health. For this we need 2 new variables. Open up the player object and go to the create event code. On a new line, type s equals 0. We're using s because score is a built-in variable that we don't need to use. Add another line and type h equals 100. We're using h for the same reason we used s. Health is also a built-in variable. With these variables set, we want the player to be able to see them. For this, we can simply draw some text to the screen. Tick off the code and then open up the draw event of the player. On a new line, type draw_text, and then add an opening and closing bracket. This function allows us to draw text directly to the screen. We need to provide it with an x and y position. Type 4 for both x and y. This will space it out a bit from the top left of the screen. Now we need to provide it with the text we want to draw. Now we could just write in the variable here and that would draw the text on the screen, but the player wouldn't know what this number means, so we need to label it. To do this, we can use the string function. This function can take a number and convert it into a string. We can then plus the 2 strings together and draw it to the screen. For the string argument, type string, opening bracket and closing bracket. In between the brackets for the string function, put a quotation mark and type health. Now put a colon and then add a space, and put in the last set of quotation marks. Make sure you put the space at the end of the first string so there is a space between that and the health value when it is drawn. Next to string,
plus, then put it in string again and add another set of brackets. In between that set of brackets, put h, which is our health variable. Now we can do the same for the score. Copy and paste the code we just wrote to a new line beneath it. Now replace the y variable with 29, which will make the text lower than the health text, and change the wording from health to score, and then change the h to s. Kick off the code and the object, and then run the game. You should see the values in the top left corner of the screen. However, there is no way of gaining score or losing health. For this we will use our enemy object. Open up the player object and then go to the collision code with the enemy. Delete all code inside this event. We want to be able to kill the enemy without being hurt. To do this, we'll give our player the ability to jump onto the enemy from above and kill it. This is fairly simple. We can use the vSpeed variable to see if the player is falling or not. If vSpeed is higher than 0, then the player is falling, so a collision is most likely happening from above. Let's program this. Type if vSpeed is higher than 0, and add a set of curly braces. So if vSpeed is higher than 0, then we want to kill the enemy. Type with, then add a set of brackets next to this. Now type other, and add a set of curly braces after that. The with function allows us to execute code through another object. This other variable is a built-in variable. In this case, other will be equal to the ID of the object we just collided with, so we can use it to reference the enemy object we are hitting. In between the curly braces, type instance underscore destroy. Then add 2 brackets to the end of it, as it is a function. Remember that the with statement will take us into the object we define. So instead of instance destroy destroying the player object, it will destroy the enemy object. The player kills the enemy, they should get some points added to their score. To do this, simply add a new line beneath the with statement, and type s plus equals 10. This will add 10 points to the score every time an enemy is killed. That's it for killing the enemy, but what if the player collides normally with the enemy? The player should lose health, and the enemy can be destroyed. To do this, type else, and then a set of curly braces. Type h minus equals 10. Now type with, opening bracket, and then other, and then another closing bracket, and then put in the curly braces. In between the curly braces, type instance underscore destroy, then add an opening and closing bracket at the end. This will take away 10 health points from the player and destroy the enemy so that we aren't continuously using 10 health points as we collide with it. Finally, we need to kill the player when the health reaches 0. To do this, tick off this code and then open the code in the collision event of the spike. Select all the code inside the event, right-click and click Copy. Now tick off the code. Now go to the step event of the player and then open up the code inside of that. At the very bottom, on a new line, type if h is lower or equal to 0, and then add some curly braces. Now paste the code in between these curly braces. This will kill the player when the health is lower or equal to 0. Tick off the code and then tick off the player object. If you haven't already, add an enemy into the game. Run your game. First, try killing the enemy by jumping on its head. Next, try losing health by letting the enemy collide with you normally. If all goes well, then when you jump on an enemy, it will be destroyed, and running into one will make you lose health. When your health reaches 0, the player should die and the game should restart. Killing an enemy should add 10 to your score. That's it for creating health and score. As you can see, keeping track of things such as score is fairly simple. You should now have a good idea of how strings can be combined, how variables can be used to keep track of score, and how you can add and subtract scores and have them affect objects. In the next section, we will look at creating simple artificial intelligence, or AI for short. In this section, we will be creating simple artificial intelligence, or AI for short. In this topic, we will learn about states. We will learn what they are used for and why they are useful when programming AI. States are used to split up an AI's activities. For example, you would have a state for when the AI is standing still. You could have another one for when the AI is looking for you, or when it is scared. You pretty much have a different state for each basic emotion or task. This makes things easier to keep track of in the long run, especially when it is an advanced AI. Such a program is known as a finite state machine. A finite state machine is basically a machine that can be in one of a certain number of states.
The first thing we need to do is create a new object for our AI. Call this object obj enemy AI. Add a create event and drag in a code block. We are now ready to go. Let's start by creating a few variables to hold the stats for the AI. This will work much the same as the player object. Type stat underscore spd equals 5. This is the AI's movement speed. To keep things simple, we won't be applying acceleration and friction to the AI. Type stat underscore grav equals 1. This is the gravity's pull power on the AI. Now type stat underscore jmp equals 10. This is the AI's jump power. Now type dir equals 1. Just like in the player object, this keeps track of the AI's direction. Finally, we can create our state variable to keep track of which state we are in. Type state equals 0. As you can see, the AI is fairly simple. The state variable will be used to keep track of which state the AI is in. It will then be changed depending on what is happening in the game, and in different states the AI will perform different actions. You should now have a good understanding of what a state is and how it is used. AIs don't require states. There are many ways to create an AI, but states are one of the easiest and simple ways to create simple or advanced AIs. In the next topic, we'll be looking at coding the states and basically making our AI work. In this video, we'll be looking at coding our states. Remember that a state is nothing but a variable that we are using to control how our object behaves in different situations. We can have one for running away or one for when it is hungry. States are extremely useful in the programming of artificial intelligence. Never assume that just because it's called artificial intelligence that it's actually smart. A lot of the time the AI is still pretty dumb. This is because it's near impossible to cover every situation that an AI might find itself in. For example, if it gets stuck between two walls, unless you have a check for this, then the AI will probably just sit there. Onto the programming. In the last topic, we set up the variables we would be using, including the state variable. We set state to 0, as this will be our default state. For this tutorial, we will use state 0 as an idle state. This means that when the AI is in state 0, it will simply stand in its current location. When programming AI, you don't have to use state 0 as an idle state. This is simply for the purpose of this tutorial. We will use state 1 as a walking state. State 1 will be our most programming heavy, as we want the AI to be able to walk up slopes a lot like the player. It's good practice to create mind maps or diagrams of what you want your AI to be able to do before you start programming. This creates a nice plan for you to look back to and check off like a list as you make your AI perform different tasks. Open the AI object. Now add a step event and drag in a code block. The first thing we need to code is our gravity. For this type, if place underscore free opening bracket x, y plus 1 closing bracket, then a set of curly braces. In between the curly braces, type gravity equals stat underscore grav. Beneath the curly braces, type else, and then another set of curly braces. In between those, type gravity equals 0. This is the same as our player's gravity. Now we need to check our state variable to see if it's equal to 0 or not. If it is, we can continue with our code. Type if state equals 0, and then add some curly braces to the end of it. Now we need to give our AI object something to do when it's in state 0. This includes a way to move onto a new state. We can use an alarm to make our object change to state 1 after a certain amount of time. Alarms work off steps, so if you set an alarm to 30 and your room speed is also 30, then your alarm will go off in 1 second. This is because the room speed is the amount of steps each second that your game performs. While we can set our alarm to be 4 or 5 seconds, with the alarm being the same every time will make our AI object look robotic, as after a while the player will notice the pattern. To solve this problem, we can use the random function to get a random number no higher than the number you give it. This way an alarm will almost always have a different value when the state is entered. Remember that the step event is executed once every step, so we can't just set the alarm, as this means the alarm will be reset each step and never actually count down. To solve this, we can check the value of the alarm to see if it has gone off or not. In between the curly braces, type if
alarm, and then opening square bracket 0 for alarm 0, and then closing square bracket. Now lower than 1. Add a set of curly braces to contain our code. This will check to see if alarm 0 has counted down to 0 or not. If it has, we can now set our alarm again. Type alarm, square bracket 0, closing square bracket, equals random, opening and closing bracket, room underscore speed, times 10. This will set alarm 0 to a random value between 1 second and 10 seconds. The room speed variable is a constant variable that holds the value of the room speed. By default, this is equal to 30. With that set, we need to change the state when the alarm goes off. Tick off the code and then add an alarm event for alarm 0. Now drag a code block into it. Type if state equals 0 and then curly braces. In between those curly braces, type state equals 1. Beneath the curly braces, type else, and then another set of curly braces, and in between those, type state equals 0. Now when this alarm goes off, if state is equal to 0, it will be set to 1, and vice versa. Tick off the alarm code and bring up the step event code again. We need to start programming state 1. On a new line, type if state equals 1 and then add a set of curly braces. We'll be using state 1 as a moving state. When in state 1, our AI will move left and right depending on the dir variable. Start by copying and pasting the alarm code into state 1. This will allow the state to change back to 0. Now we can do the actual programming. We will be using a while loop to do our movement, as it allows for us to check for a slope. If there is a slope we can go up, we will change the AI's x and y position. If not, we will change the direction and go back the other way. Type if dir equals 1 and then add a set of curly braces. Now type var I equals 0. Beneath that, type while I is lower than 12, then add another set of curly braces. In between those, type if place underscore free, then add an opening and closing bracket, type x plus stat underscore spd, and y minus I. Now add another set of curly braces. Now type x plus equals stat underscore spd, and y minus equals I. Beneath that, type break. Now within the while loop, and outside of the place free check, type I++. Now outside of the while loop, but still inside the dir check, type if I equals 12, then add another set of curly braces. And type dir equals -1. Remember to check which curly brace goes with which, highlight one of the curly braces, and its component curly brace will highlight also. So as you can see, we start by checking the direction. We then set I to 0 and start our while loop. We check to see if the place is free, and if it is, we move and end the loop. If not, we add 1 to I and run the loop again. To find out if we have or haven't moved, we check to see if I is equal to 12 by the end of the loop. If it is, then we have most likely hit a wall or the slope is too steep to walk up. We then set dir to -1, which switches our direction. Now we need to repeat the code for when dir equals -1, and instead of adding to our x value, we subtract from it and move left. On a new line, type if dir equals 1 and then a set of curly braces. On a new line, type if dir equals -1 and then a set of curly braces. Beneath the previous dir check, type if dir equals -1 and then add a set of curly braces. Now copy all the code within the first dir check and paste it into the new one. Now we can simply change small parts of the code to suit what we need. The first change we need to make is in the place free check. Change it from x plus stat speed to x minus stat speed. Then directly beneath that, change it from x plus equals stat speed to x minus equals stat speed. And the final thing we need to change is within the if I equals 12 check. Change it from dir equals -1 to dir equals 1. That's it for state 1. Now all we need to do is make our AI collide with the ground. Tick off the step event code and add a collision event with the ground parent. Now drag in a code block. This code will be the same as the collision event for our player object with the ground. Type move underscore contact underscore solid and add an opening and closing bracket. In between those brackets type direction for the first argument and then 12. Now in a new line type vSpeed equals 0. The first line moves the object so that it is meeting the ground object when it is within 12 pixels of the collision. The second line simply sets the vertical speed to 0 and stops it from falling through the ground. The only thing left to do is give your AI a sprite. Tick off the code and for now just use the same sprite as the normal enemy. You can now add your AI into your game room and run your game. Within 10 seconds your AI should start moving. After a little more time it should stop again and repeat the process. That's it for this video. You should now have a good understanding of states and how simple AI works. In the next video, we will make our AI a little smarter and make it able to attack the player. In this video, we will be improving our AI by allowing it to chase and kill the player. We will also make our player able to kill the AI. To begin with, open the AI object and then open the step event code. Go right down to the bottom and add a new line. On the new line, type if state equals 2, then add a set of curly braces. State 2 will be our chase state. In this state, we will use the player's x variable and our own to determine which way we need to move. We will then change the direction of the AI. Inside the curly braces, type if obj underscore player dot x is higher than x, and then add a set of curly braces. Now type dir equals 1. Beneath that set of curly braces, type if obj underscore player dot x is lower than x, and then add another set of curly braces. In between those, type dir equals -1. This code begins by checking if the player's x value is higher than the AI's x value. If it is, we know that the player is to the right of us, and we set our direction to the right. We then do another check to see if the player's x value is lower than the AI's. If it is, we set the AI's direction to the left. We now need to make it move depending on its direction. For this we can simply copy and paste the movement code from state 1, as it will work the same and saves us work. Do this now. The only thing we need to do is take away the direction changes when the AI can't move past the wall. Just take away the two if I equals 12 statements from those pieces of code. Once this is copied, we have the basics of this state. However, we don't want to be chasing the player forever. We need to check if the player is out of sight or not. For this we can use a collision line. A collision line checks for a collision between 2 points that you set. In this case, we'll be checking for a collision with a wall in between the AI and the player object. On a new line, type if collision underscore line, then opening and closing bracket. For x and y1, we need to type x and y for the AI's x and y position. For the second x and y position, we need to type obj underscore player dot x and obj underscore player dot y for the player's x and y position. The collision line will then be between those 2 points. For the next argument, we need to tell it which object it needs to check for a collision with. In this case, it's obj underscore ground underscore parent. Set precise collisions to true, and then not me, which means it won't sense a collision with this object. Set that to true as well. Now add another set of curly braces. This is our collision line being checked. So if a ground object collides on any point between the x and y values set, then that means the AI cannot see the player. In between the curly braces, type if alarm 0 is lower than 1, then add another set of curly braces. In between that set, type alarm bracket 0 bracket equals random opening and closing bracket, and then room underscore speed times 3. Here we are simply setting our alarm so that the AI will stop chasing within 3 seconds of the player being out of sight. For the AI to actually stop chasing the player, we need to add some code to our alarm event. Tick off the step event code and then reopen the alarm. Tick off the step event code and then open the alarm event code. On a new line, type if state equals 2, and add a set of curly braces. In between those curly braces, type state equals 0. This will set the state to 0 if the alarm goes off and the state is currently equal to 2. The last thing we need to do is make a way for the AI to actually get into state 2. For this we need to reopen the step event code. In between state 1 and state 2 code, add a few new lines and type if state equals 0 or state equals 1, then add a set of curly braces. In between those, type if not collision underscore line, then add a set of brackets. In between the brackets, type x, y, obj, player.x, obj, player.y, obj underscore ground underscore parent, true, and true. This is the same as the previous collision line we did, except in this case we're checking for when there isn't a collision. Add another set of curly braces. In between those, type state equals 2. Code starts by checking if state is equal to either 0 or 1. If it is, it checks to see if there is not a collision along the line between the AI and the player. If there is no collision, it means the player is in sight and sets the state to 2, making the AI begin its chase. Tick off the code and AI object, then add an AI object to your room if you haven't already. For this I will redesign the level. We can now run our game. If all goes well, the AI should chase you when it sees you and stop when you go out of sight. Now all we need to do is make it so that we can kill the AI and vice versa. Close the game. For this we simply open the player object, right click on the collision event with the enemy object, click duplicate event, and choose a collision event with the AI object. This will duplicate the code and we can now kill and be killed by the AI object the same way we are by the normal enemy. Run your game again and you will be able to kill and be killed by the AI object. That concludes this topic. You should now have a developed understanding of how states and AI objects work. Once again, states are not essential as there are many ways to make artificial intelligence. It is, however, organized and easy to learn. Not only does this conclude this topic, but it also marks the end of this video course. During this course, you have learned about the GameMaker interface, GameMaker language, creating objects and assigning properties, basic animation, movement and object interaction, advanced movement, implementing gameplay features, and creating simple artificial intelligence. With all this, we have created a simple platformer game. Congratulations on completing this course. With this knowledge and a little more work, you can create your very own games as advanced as Super Mario or Super Meat Boy. It is always important to stay headstrong. If you need to know something, search the internet and you will almost always find the answer you're looking for. Remember that the GameMaker community is filled with developers that will help you with any questions you have regarding GameMaker and its components. Good luck creating your own awesome game with GameMaker Studio.